So, how do you build a massive app, one that runs on phones, tablets, and desktops, that doesn't completely fall apart the second you try to change something? Well, today we're going to dive into the architectural patterns that make it all possible. For this explainer, we're leaning heavily on an incredible ebook from Microsoft called Enterprise Application Patterns Using .NET MAUI. Honestly, it's a fantastic guide that really lays out the blueprint for building these huge, robust applications. And we're going to use their sample app eShop as our case study. I mean, just look at this thing. It's a full-featured online store. So here's the big question. How do you architect something this complex so you can update it, fix bugs, and add new features without it turning into an absolute nightmare for your developers? And that really is the core challenge, isn't it? The source material makes it super clear that enterprise apps are always changing. They're living things. You need an architecture that isn't just going to work today, but one that's flexible and can grow. A rigid, tangled code base, that's just not going to cut it. All right, so here's our game plan. We'll kick things off with the MVVM blueprint, then we'll see how dependency injection helps us put all the pieces together. After that, we'll look at how these separate parts actually talk to each other, how the whole system handles real-world problems, and finally, what the big payoff is for all this careful planning. Let's start right at the foundation. One of the biggest traps in app development is letting your user interface code get all tangled up with your business logic. The solution is a really powerful pattern called Model View View Model, or just MVVM for short. Okay, so on the left, you've got the messy way, the spaghetti code approach. You go to change a button color, and suddenly your entire checkout logic breaks. It's a mess. But on the right, you have the clean separation of MVVM. It neatly divides the app into these distinct parts that don't step on each other's toes, which makes everything way easier to manage and test. What's so brilliant about this diagram are the arrows, and specifically the direction they're pointing. It shows this one-way flow of knowledge. The view knows about the view model, and the view model knows about the model. But, and this is the important part, the model has no idea the view model exists, and the view model knows absolutely nothing about the view. That right there, that's the secret sauce. So let's break it down real simple. The view, that's just what's on the screen. The buttons, the images, the layout. The view model, that's the brains of the operation. It holds all the data and the commands that the view needs to function. And the model, well, that's just the raw data and the business rules, often just simple data objects. You might hear them called DTOs or POGOs. Each part has one clear job to do. That's it. Okay, so MVVM gives us these wonderfully separate components, but how do we actually connect them without just creating a new kind of tangled mess? Like, if a view model needs some service to go get data, it really shouldn't be in charge of creating that service itself. And that's where our next pattern comes into play. Think about it like this. You want to build something with Lego bricks that are totally independent, right? Each piece can be swapped out, you can test it all by itself, and it doesn't care who made the brick you snapped it onto. How do you pull that off? Well, the answer is dependency injection, or DI. Instead of a class building its own tools, it just asks for them. An external container is in charge of figuring out which tools to provide and when. It's kind of like a professional kitchen. The head chef doesn't grow her own tomatoes. A central supply service delivers exactly what she needs right when she needs it. And the benefits here are just huge. The ebook points out three big ones. First, testability goes through the roof because you can just swap in fake mock services when you're running your tests. Maintainability gets a huge boost because adding new stuff is way easier. And most importantly, it dramatically reduces the coupling, that tight connection between all your different components. Okay, but this brings up a pretty logical question. If all our components are so nicely separated and independent, how on earth do they talk to each other? If a user clicks a button on one screen, how does some other part of the app know that it needs to update? Well, for moving between screens, the architecture uses a dedicated navigation service. A view model doesn't say, hey, go to the profile view screen. Nope. It just says, hey, navigate to the profile route. This service then takes that request and figures it out, which completely disconnects the view model from any specific UI. And for pretty much everything else, the ebook uses a publish-subscribe pattern. The easiest way to think about this is like a public announcement system or a radio station. One component can broadcast a message, like, hey, a product was just added to the cart, to a central messenger. Then, other components who care about that can be tuned into that station and react when they hear the message. The best part? The sender and the receiver never even have to know the other one exists. All right, let's talk about the messy, real-world stuff.
Any serious app has to fetch data from somewhere, it has to validate what the user types in, and it's got to handle security. So how do these patterns help with all of that?
Let's start with data. The eShop app is pulling all its information from a backend that's built with microservices. The architecture is designed to keep all that data access logic totally separate in its own dedicated services. This means the app can talk to all these remote sources, and the user interface doesn't need to know a single thing about how or where the data comes from.
Next up, validation. You can't just trust user input, so the ebook shows this really clever pattern. Any piece of data that needs to be checked is wrapped in something called a validatable object. Think of it as a little container that holds the value, all the rules for what makes it valid, and a little flag that says, yep, it's good, or nope, it's bad. It keeps all that validation logic neatly packaged up, and the UI can easily show an error if it needs to.
And of course, security. By making things like authentication and authorization their own dedicated services, the architecture makes sure that protecting your app is a centralized, manageable process. The app uses a system called Identity Server, which is basically like a bouncer at a club, handing out tokens and securing access to the APIs. So after seeing all of this structure and all these different patterns, you might be sitting there thinking, why? Why go through all this trouble? What's the big payoff? Well, the payoff for all this planning is absolutely massive. What you get is an application that's adaptable, maintainable, and testable. You can easily pivot when the business changes its mind, you can fix a bug without causing a chain reaction of new problems, and you can test every little piece in total isolation. This is what separates a successful, long-lasting project from a code base that just collapses under its own weight. And this quote from the ebook really just hits the nail on the head. The goal isn't just to ship an app that works right now. The goal is to build an app that can adapt and grow for years to come. That is the real power of good architecture. And that kind of leaves us with a final thought to chew on. In this world of modern software that's always evolving, is it possible that the architecture, the actual blueprint for how all the pieces fit together, is more important than any single line of code? Something to think about. Thanks for watching.